Okay, we're going to do a practice quiz, chapter review, page 118, a whole bunch of problems. Number one wants to know the length of the curve between the point 1, 1 and 3, 9. Because it's a curve, you could find it using this arc length formula. However, that requires calculus. So, because we don't know integrals, we don't know how to do this yet. So it's going to be something close to that. Could I do a straight distance formula between the 2 points? Would that be one way of approximating it? Well, then let's do the distance formula. X minus x quantity squared, so let's do 3 minus 1 and 9 minus 1. So you get this 2 squared is 4. 8 squared is 64. We have about the square root of 68. I'm going to assume that's about 8.3, which is an approximation of the actual arc length. So what I did was I set up my table on number 4. I put in y equals on my calculator, and I did a table. And that table gives me the following answers: 0.2516. 0.2502. The next one says 0.25. If you actually highlight it, it will probably give you the more accurate value on the bottom there. So that is 0.25001, 0.25001. And they gave me basically these values, 0.2498, and what is it, 0.2485. Again, I got all these values using my calculator. On number 14, I'm going to substitute in a -5, giving me my result. Okay, from 14, we're moving to 20. 20, if you put in a 0, gives you 2 minus 2, which is 0, divided by 0. So I have to somehow get rid of or rationalize, because there are radicals. A minus b's conjugate is a plus b. When you multiply those, you get a squared minus b squared. So the conjugate is going to be, I think we've done enough of these, right? The conjugate is going to be, instead of radical minus 2, it's going to be the radical plus 2. Now, if this is a, what's a squared? 4 plus x. If this is b, b squared is 4, making the numerator just x, which will cancel with the numerator that has a factor of x. So you have this in your denominator. And when you put in a 0 for that x, you get 1 over 2 plus 2, or 1/4. That's rationalizing. The next one, you have to do the common denominator and rationalize. This next one is going to be one of the more difficult ones for a lot of people if you're algebraically challenged. The common denominator, you just multiply by your 2 denominators, which in this case really is only one of them. So I'm going to multiply by this over itself, 1 plus x. When I multiply here, these cancel, leaving me a 1. When I take this times 1, I get itself, radical 1 plus x. On the denominator, you have these. Now we're going to rationalize again. The conjugate of a minus b is going to be a plus b. When you multiply those, you get a squared minus b squared. So the conjugate is going to be 1 plus the radical. Now, if this is a squared would be 1. Always use parentheses when you subtract. If this is b, what's b squared? If you simplify your numerator, 1 minus 1 gives you 0, and then you're left with a negative x. That x and the negative x can cancel with the x in the denominator, leaving me negative 1 over this times this. And now on our problem, x was approaching 0. So I'm going to put zeros in for these x's. I get 1 and 1 plus 1. So I believe that would give me a negative 1/2. Okay, on to number 24. I think you can put pi over 4 directly in. If you put pi over 4 in, the numerator gives me just pi. Tangent of pi over 4 is 1, so the result is pi. Okay, I'm going to modify this. We're not going to do number 27, but I do think 26 is a good problem. 26 is knowing your properties of logs. There are a few of them. In fact, it's 3 of them. Do we know what to do with log of a to the b power? Do you know that you can pull your exponent out front of a logarithm? So I could pull this 2 out front of the logarithm, at which point the logarithms cancel. You couldn't put a 2 in originally because it gave you ln of 1 over ln of 1, which is this. So you can't do that, but you can use properties to try to simplify it. So your result is 2. Okay, from 26 we go to 33. If you put 0 directly in, you get 0 over 0. I see radicals, which tells me conjugates. A conjugate of a minus b is again a plus b. When you multiply those, you get a squared minus b squared. So your conjugate is going to be the radical of 2x plus 9 plus 3. Divided by itself, so that's a fancy form of 1, and you're not changing the value. So if this is a squared would be 2x plus 9 without the square root. I always use parentheses. 3 squared is 9. So you end up with simply a 2x in the numerator. And the denominator, you have all of this. Cancel your x's, leaves me a 2 on top. 2x plus 9 and plus 3. We're doing the limit as x approaches 0. So I'm going to replace the x with 0, making the square root of 9 plus 3, so you get 2/6, which simplifies to 1/3. Okay, that was a conjugate. This one's a common denominator. So your common denominator would be x plus 4 times 4, x plus 4 times 4. When you use a conjugate, these multiply. I'm sorry, when you use a conjugate, you have a sign between them, either plus or minus. Whereas if you're doing a common denominator, these are multiplied. Anyway, when I multiply here, the x plus 4's cancel, leaving me the 4. Here I'm going to multiply, the 4's would cancel, leaving me the x plus 4. When I distribute, 4 and a negative 4 is 0, leaving me just negative x in the numerator. Canceling those, don't forget there's a 1 on top. And I can now replace the x's with zeros. So I'll put in a 0, and I get negative 1 over 4 times 4. I always try direct substitution first. If you put 0 in, you get 1/4 minus 1/4, which is 0 over 0. So try direct substitution first. Can you put a 3 directly into this? I think you could put a 3 directly into this. It's 3 from the left, but if you put a 3 directly in, you'd get your answer like such. Now, if it was approaching negative 3 from the left, the limit would either be negative infinity or positive infinity. And at this point, I'd even accept does not exist, because infinity does not exist. 41, I'm probably going to do 2 different ways. So if you don't mind, I'll probably just rewrite it over here so that I can do it in a different way. If I put a 4 directly in for direct substitution, I get 0 over 0. That does not allow me to do anything. I do see radicals, though, so I think conjugates. A minus b's conjugate is a plus b. When you multiply, you get a squared minus b squared. So this would be radical x plus 2, radical x plus 2. If this is a squared's x. If this is b, b squared is 4. In the denominator, you have all of this. I think the x minus 4's could cancel. You'd have 1 over this. And we're doing the limit as x approaches, in this case, x is approaching 4, right? So if I put a 4 directly in, I get 1 over 2 plus 2, which should give me 1/4. Okay, here's another approach to 41. I just want to know, how do you factor x squared minus 1, x squared minus 4, x squared minus 9? You factor them as a difference of squares, don't you? So this would be x plus 2, x minus 2. This last one will be x plus 3 times x minus 3. Where does the x and the 3 come from? Are they the square roots of these? So my question is, can you factor your numerator? I'm sorry, your denominator. A lot of people say x minus 4 cannot be factored. But what's the square root of each one? Could it be this times this? In which case, these would cancel. And if I put in the x as a, and what was x approaching? 0, no, x was approaching 4. So if you put a 4 in, do I still get the same result? That's just what I call creative factoring. It's your choice. You can also use the conjugate on this one. Okay, this is a split domain, or what's called a piecewise function. This is split at 2. This is also where the limit as x is approaching is also 2. So I have to make sure it approaches the same value from the left, which would be less than 2, as it does from the right, which would be greater than 2. Pretty much the simplest way is put 2 into both and see if you get the same value, and that would be your limit. 2 from the left, let me use something that writes. The limit as x approaches 2 from the left of my function, I'd put in a 2 into here and get out a 0. The limit as it approaches 2 from the right, that means bigger than 2 would mean this one, so I put a 2 into there. Since they are the same, this limit will equal 2. I apologize. That's not the y value you end up with, is it? It's not 2. What should it be? The limit should be 0 because that's the y values we ended up with. I apologize. X was approaching 2, but the limit is 0. In this problem, they want to know about the discontinuities. Discontinuities happen when you get division by 0. So I'm going to factor my denominator. I'm going to factor it a little bit further, which I think would be x plus 1, x minus 1, making this discontinuous at 3 x values. At 0, at -1, and at +1. because that's what makes each of these equal 0. One of them is removed. That would be the 0, and that makes that the removable discontinuity. The ones that do not remove are vertical asymptotes. If they make the denominator 0 and do not cancel, they are vertical asymptotes. If they cancel, they're removable discontinuities, also known as holes. Okay, after 49, I think we go to 50. It's x plus 3 divided by x squared minus 3x minus 18. So I'm going to factor the top, which is already factored. If something canceled, you might have an x plus 3. 3 times what is negative 18? Basically, just factor the denominator. And I think they multiply to negative 18 and add to negative 3. So there's two values that make this denominator 0. So this is discontinuous at x equals negative 3 and x equals 6. One of them is removed. That would be the negative 3. So that's a removable discontinuity. And the one that doesn't cancel is called a vertical asymptote. I'm going to do a quick example of what the intermediate value theorem is. If you had a parabola that went through the point 1, 1, and then went through this point up here, 3, 9, and the function is continuous, it has to be continuous. If that's the case, somewhere between them, you would have to have a y value of, let's say, 5. Can it go from 1 to 9 without passing through 5? Somewhere it can't. Same thing here. 59, if you put in a 0, what do you get out? Negative 3. If you put in a 1, what do you get out? 2 minus 3, negative 1, right? I was wondering, I have the wrong interval here. It's not 0 to 1. This interval is what? 1 to 2. If you put in a 1, what do we get out? 2 minus 3, negative 1. If you put in a 2, you get 8. 16 minus 2, 13. Can it go from a negative to a positive without somewhere crossing through a 0? That's what they're saying. They are showing that it has a 0 on the given interval. On my example, I was showing that it had a 5 on the given interval. But most of the time it's used to show there's a 0. So basically you put in one endpoint, get a y value. Put the other endpoint in, get its y value. I was trying to show there's a 0. Is 0 between negative 1 and 13? Yes. After 59, we're going to 73. Okay, after 59 is 73. It is a limit as x approaches 0 from the right. Limit as x approaches 0 from the right. And it's x minus 1 over x to the third. X minus 1 over x to the third. If I put in a 0, I believe I get this. And I think I may have tried to tell you that a constant over 0 is infinity, and a constant over infinity is 0. This happens to be a constant over what? This is a constant over 0, which we know is what? Infinite. However, if I go from the right of 0, that would be like not putting in a 0. That would be from the right would be a positive 0.001, let's say. So anyway, I think that gives me a positive infinity. 0 minus infinity is negative infinity. Now, we can try another way. We could try to write it as a common denominator. Okay, to do this one, you need to know that the limit of y is approaching 0 of the sine of y over y would be 1. In other words, as long as these are the same and it's approaching 0, you get a 1. 4 and 5 are not the same. So I'm going to try to make them the same. I'm going to take that 1/5 out and just make sure this is exactly what it's supposed to be, the same. Now I'm going to multiply by 4 over 4. And now I think I have 1/5. There's a 4 at the end. Well, I want 4 over 4. I just put the 1 underneath there. Now, I did that so that I could try to show that now these are the same and this limit is 1. So when you multiply these, you should just get 4/5. A lot of people know that it's just going to be that part of it. But I'd like you to know why. In reality, I did 4 over 4 because you have this 4 over this 4. I just happen to put the 1 there.